Hello, in this video we are going to look at how to find equations of perpendicular lines. So far we have looked at how to find the gradient of the line, how to find the midpoint, and how to find the distance between 2 points. And finally we looked at how to find or write the equations of parallel lines. But in this video, we are going to focus on finding the equations of perpendicular lines. Okay, so let's do that after this short break. Okay, so here is an example. Find the equation of the line that is perpendicular to the line of the equation y is equal to 2x minus 3 and passes through the point -5, 3. So the first thing is to find the gradient of the given equation. So first of all, let's rewrite the given equation and find the gradient. So we have y is equal to 2x minus 3. So for us to find the gradient of the given line, we need to make sure that the given line is in the form y is equal to mx plus c, where m is the gradient. So m is the gradient. So we need to find the gradient of the given line. So when we observe the first equation or the given equation, we discover that it's already in the form y is equal to mx plus c. Okay, and here where there's m in the first equation, there's 2. So meaning the gradient, so we're going to say the gradient m is equal to 2. So the gradient of the first equation is 2. So because this is the first equation or the given equation, we are going to say this is m1, meaning the gradient of the first equation. Okay, so from there, the other important thing that you are supposed to know about perpendicular lines meaning the lines that are cutting or that are crossing each other at 90 degrees. So the other important thing that you're supposed to know about perpendicular lines is that when you multiply the gradients of these perpendicular lines, you should get -1. So what I'm saying is, if you multiply the first gradient, the gradient of the first equation times the gradient of the second equation, you should get -1. Okay, so in this case, we have m1. So where there's m1, we're going to put a 2 there. So 2 times m2, we're going to have 2m2 is equal to -1. So our aim is to find m2. So we're going to divide both sides of this equation by 2, like that. So the 2's cancel. Then we have m2 being equal to -half. So this is the gradient of the second equation. Okay, so now we are going to use, this means that we are going to use this gradient of the second equation and the given point to come up with an equation that is parallel to this, that is perpendicular to this given equation. So from the previous video, we introduced a formula on how to find, or the formula that is used to find straight lines. So this is a formula that we said y minus y1 is equal to m Now, because this m we are referring to the second gradient, which is the gradient of the second equation, so we're going to put this m2 here, m2 x minus x1. So this is the general formula for finding the equation. So when you look at these points, these are the points that we're going to use to find the equation of the line that is parallel to this given line. So when you look at these points, you have the first coordinate here is for x, 1, and then this one will be y, 1. So now we can replace in the formula. So we have y minus y1 is 3, so we're going to say 3 is equal to m2. We found that m2 is negative half. So we're going to put negative half x minus x1. x1 is negative 5. So we're going to put negative 5 in brackets like this. Okay, so we need to simplify this. We are going to have y minus 3 is equal to negative half x. Negative times negative will be positive. So we are going to have positive 5 in the brackets like this. So now we have y minus 3 is equal to negative half times x is negative 1 over 2, or negative half x. Then negative half times positive 5, we have minus 5 over 2. We have minus 5 over 2. So remember our equation. So at the moment, this is also the equation of the line that is parallel to, that is perpendicular to this line. So we need to make sure that we write this equation in the form y is equal to mx plus c. So meaning we have y minus 3 is equal to negative half x minus 5 over 2. So on the left hand side, we need to remain with y alone so that we have this form. So meaning the other term, which is negative 3, has to be removed from the left hand side. So we're going to remove negative 3 by additive inverse. So this is negative 3. We are going to add 3 both sides. So what we've done on the left hand side, we also do it on the right hand side. Okay. You also do the same on the right hand side. So now so that when we say negative 3 plus 3, this will be a 0, and then what will remain is y is equal to negative half x negative 5 over 2, negative 5 over 2, then plus 3, plus 3, plus 3 like this, plus 3 like this. Okay? So this 3 is over 1, so we can solve this. So we're going to have y is equal to negative half x. So the common denominator is 2. So meaning we can write this as equivalent fraction. We can solve this equation by multiplying by 2. We have 1 times 2, so that we have 2. We also do the same on the numerator. So we're going to have negative 5 over 2 plus 3 times 2 is 6 over 2. Is 6 over 2. Now we can say negative 1 over 2x. Negative 5 plus 6 is actually positive 1 over 2. So when you look at this equation is actually in the form y is equal to mx plus c. You can either leave it like this, or you can factorize the half, okay? You can factorize the half or the negative half. So you're going to have y is equal to negative half, then x minus, when you remove the half, you have 1 there. So this is the line. This is the equation of the line that is perpendicular to this given line here. This given line. So if you are new to this channel, please consider subscribing. See you in the next video. The next videos we're going to be looking at bearing. So if you want to learn more about bearings, this is your time. All you have to do is just to subscribe to my channel and make sure that you turn on the notification bell so that whenever I post a video, you are notified. All right. Goodbye.